Okay, let's get started. Anybody talk about what they were able to do with this October competition last week? Fortunately, I think Steve is not going to be able to join us. And Rekul said he was flying back. He might be able to join, but I haven't heard from him this morning. You know, those two have been active.
I haven't done much in this competition, but I have looked at the five-fold CV notebook that you provided some comments on the Slack for.
Yeah.
Yeah, so I was wondering, could you please explain it in a brief way? That notebook.
Sure. Let me share my screen. Actually, there seems to be, I kind of confirmed this offline with when I was talking to Raquel as well. So can you see my screen now?
Yeah.
Okay, so I will use this to kind of explain first the different experiments I was trying, and then kind of we can get into a little bit more of the notebook itself, if you will. I'll kind of first talk a little bit abstractly, but then we'll get into the details. But so one of the things I'll explain when we look at this five-fold CV, where it's not just the five-fold, because many other notebooks do five-fold CV. I mean, that's not unique, but he claims to be doing and attempts to do combinatorially purged CV. And
Okay.
I think I pointed to the book previously last week that talks about this technique. Honestly, I still am trying to get my head wrapped around the details of the technique, but I will, because there are some aspects of it which aren't 100% clear to me. There are still some questions, but I'll get to those in a minute, or what is still open and what I understand. But one of the issues, as we will see when we go through this notebook, is the fact that while he claims to do combinatorially purged CV, which if you look at the book and the pointer to it, even in the chat Slack or whatever the pointers earlier shared in Slack, the goal of that is to not allow leakage and to prevent the usage of relevant information from the training to leak into the test or vice versa. But what we'll see if we look at the details of this notebook, which I'll open in a minute and get into, is that he actually does not do that. There is a significant overlap of training and test data in the CV folds in this notebook. So it's kind of puzzling, and it may just be sheer chance by which he gets a much better score than on the public leaderboard, which obviously is data hidden from anything or new data, right? It's not data that you access or is available to you during training. So therefore, while the score is good and it's kind of unambiguously good in the sense that it's obviously extracted from data that the model hasn't seen, because that's what is, the public leaderboard. However, the CV method that he uses, while the method itself intends to prevent leakage, I think the way he has implemented it allows for significant leakage. So it's kind of still a puzzle as to how he gets a better score. So what I did, and we'll look at this notebook, is I modified the 5-fold CV to actually not allow any leakage. And in each of these folds, maybe we can, I modified it, and in order to prevent leakage, and use only one fold in the test set, just like he does here. But however, in this case, he allows the training set to also have the test set. That's data, which is why I call it leakage. And if you eliminate the leakage, you see that the score actually worsens by the model that I created using CV, which is more accurate, but it results in a poorer score. The other thing then I did also, and we'll look at this as well, is I enhanced the test set to include more data than just a single fold of the 5 folds, while still preventing leakage. And you can see that when I did that, and actually the other thing is, in this particular case, I only used one fold for training and one fold for testing. So each combination of train and test is just one fold to train and one fold to test. In this fork, I used multiple folds as part of the training. So my training set is bigger than my test set, and my test set also includes multiple folds. And that gave me, you can see, a better score, but not still getting to the best score, which actually includes leakage. And then this one was just an attempt with, as Steve had mentioned, you could run a same folds, same notebook, but with different random states or different seeds. And he said he was seeing slightly different scores, and you could therefore you could combine the model. I haven't combined the models yet, but I just ran one same as this, but with different seed, different random seed, and that gave me the same score as here. And I intend to do that a couple more times to see whether it changes. Now let's look at what I mean by why I see this. So here I won't put you with all the.
Did the data leakage situation rectified, or?
No, not in this notebook. In this notebook, I just want to show you why I think data leakage, and show you how he creates the folds, and he actually does follow what the guy in the book describes in creating gaps between a training and a test set. So the intent of purging, and it's called combinatorially purged, and the combinatorial is something that's more useful in case you want to do continuous test sets which follow each other. And the purpose, at least as I understand it, and we'll discuss more when Rakil is back, because I had also asked him to look into CPCV a little more in detail, and he and I were exchanging text offline. He didn't have time last week, but he may spend some time on it this week. But the purpose of, I think, the sequence there of the combinatorial word is precisely to allow for something like gain or loss to be determined, because then you can, because the way the combinations are arranged is time in tests one after the other, and we'll look at that in a minute of what I explained. But if you ignore the combinatorial part, the rest of the term, the purged CV, is essentially purging data in order to not allow test to use or test and data to leak into the training set. But in this case, he purges the time steps, but unfortunately, he includes text data in the training data as well, which is why I say that it's leakage. And the way in this particular cell is where he does the splitting. So essentially, you have 480 time steps. Remember that there are 200 stocks in each time step, and there are 55 seconds or 55 time steps in each for each of those stocks. So each day has 200 stocks. some days, some stocks are missing, but ignore that for a minute for our purposes. So there are 480 days, and each day has 200 stocks, and each of the 200 stocks, we get the values over 55 time steps. If on a day a particular stock exists, then all of the 55 time steps exist. So for dividing into folds, we just look at the 480, which is the days. So remember that there is 0 to 480. That's what is the, and we divide it into 5 folds. So 480 by number of folds. So the size of the number of days in each fold is 96. So you can think of the first fold as going from 0 to 96, the second from 96 to 192, the third from 192 to 288, the fourth from 288 to 384, and then the fifth one from 384 to 480. That's the 96 steps that you take in each fold. Now, here, what he does, and in fact, I believe that this is where he gets stuff mixed up, is he kind of says that no need to purge after the last fold, but I don't think that that's what he does here. But he purges and calls the purge start and purge end. So remember what I just said, that the first fold, that is the 0th index, starts at 0 and goes up to 96. So that's why this is start is I times fold size, and I is 0, so start is 0. End is start plus fold size, so this is at 96. So let's look at what happens here. So purge start is n minus 2. So purge start is 94, which is, you want to give us a couple of steps shorter than the 96. So you move the end to 94. The purged end, for example, is end, and he has defined gap to be 5 here. So purged end is 96 plus a gap 5 plus 2. So 7 plus 96 is 103. So he creates a gap from the end, 96, 2 steps back, 94, 96 plus 7 to 103. Now, when he does the train indices, so you start with date ID is greater than or equal to start. So this means that date ID is greater than 0. And then date ID is less than purge start. So this would be greater than 0 and less than 94. So that's obviously the first fold. Now, what he does here, though, is he also then, and I'll have to move. I still want to be editing this, but let me just tell you that the last one, date ID, I have it written down here, what it is. Oh, the date ID is greater than purged end. So he wants to utilize the first fold, which is short of purge start, so 0 to 94, so 94 days in the beginning, or date ID is greater than purged end. So that means he wants to go, and the purged end here would mean 103 onwards, because we remember that we just calculated this to be end 96 plus gap 5, 101 plus 2, 103. This part, I think, is where the mistake lies, because now what he has done is he has taken all of these, here you see date ID is greater than purged end. So that means it's basically everything beyond 103 as well, right? And if this is the case for I less than num fold minus 1, which is the case for 0. The test indices, if you see, are date ID is greater than or equal to n, and date ID is less than n plus fold size. So the greater than or equal to n would mean that you would take date ID is greater than, in this case, n is 96. So you'll say greater than 96 and the second fold. So the intent, as I understand it, is to use the first fold to train, and the test indices, which would be the second fold. But instead, what happens here is he has used all the folds because of this OR function here in the train indices. So the train indices now overlap with the test indices, right? And then you can do the math similarly for all of the rest. And in each case, he just uses the next fold. So for example, in 0, he uses the second fold to validate. So which means that when the index is 0, he uses index 1, which means, again, if you forget the 0 index and just say 1 to 5 folds, then for the first fold, he uses the second fold as the test. For the second fold, he uses the third fold as the test, and so on, right? So for the first, second, third, fourth, fifth. And for the very last one, because you'll be short of one, he just uses the last single date. So it's just 480, because obviously there is no n plus fold size for the fifth fold, right? It will send you past 480, which you do not have in the training data. So then he just uses the 480th day as the test. So in that case, he's just using 1 day while training on an entire fold of 96 days. But for every other case, he uses trains on 96. He intends to train on 96 and then validate on the next 96, but that's not what he does because of this date ID is greater than purge time. That includes all the other folds. So this is why I think if you kind of do the math and, cut it down in terms of, you'll find that is overlapping. The test and train dates are overlapping. So the test data is in the training data, and therefore your prediction in a sense is not valid. But again, keep in mind that he builds the folds. Also, what he does is he kind of uses the folds to figure out, and I already posted what ChatGPT said why he does this, which is to say that he kind of saves it and then he evaluates the folds, obviously, but then finds the best iteration and uses that to create the number of estimators for a fold, which he then proceeds to train on the entire data. He includes this as one of the models in the models that he uses, because ultimately he uses an ensemble of these 5 or 6 models, the folded 5 models, as well as the additional model that he has used by changing or by training the model that he determines the number of estimators for using the average best iteration from these 5 folds in addition to the 5-fold model to determine the final results, right? So this is why I say that even though he has tried to do the right thing by purging and also creating a gap on the other side of the end, he hasn't effectively implemented the CPCV method. And if I proceed to show you, and I have to search which one of these, maybe I'll just back. Okay, so if you look at this notebook of mine, where I try to clean it up and not use or not allow leakage, then what I do is I remove the last OR, which is problematic thing. So here you can see there is no OR data is greater than purge. So what this notebook of mine does is it just trains on one fold. So it trains on fold 1, validates on fold 2, trains on fold 2, validates on fold 3, and it proceeds. And the last one, obviously, when I do that, I have the same problem, right? So I cannot, at the fourth or the fifth fold, if I train on the fifth fold, then, to test, I have nothing left because there's no folds beyond that. So then I just train it, I just test it, I should say, on the 480th day, right? So it's 480. So it becomes data ID is greater than or equal to end, and because of the equal to end, I get 480. And obviously, this is a null because there's no data IDs when you add n plus fold size. So there's then that's why I did this. And you can see that when I do that, the score actually drops. Now, as I just mentioned to you, the thing I did here was to only allow one fold to, or use one fold to train and one fold to test. But I thought, that may not be the most, the best thing to do. You would want more in the training and less, or at least additional data in training compared to test. So that's what was my attempt to do here. And I didn't bother because I was just playing around with this to code it to do things automatically. I just hard coded the dates. So you can see what I did here is if it's 0, then I want if the fold is 0, that means it's the first fold. And here's what I wanted to do. Say greater than 0 and less than 94. So I'm using the purge game. So I'm just using the 0 to 94. And then I'm using all the dates except the second fold dates, which is still valid. I'm using beyond the purged end of the second fold. So you can see there is a gap between the 286 and the 295 that I started. And then I use all of the data all the way from 295 less than 480. And between 103 and 286 is my second fold. And that is what I use as the test set. So you can see that this is, in fact, precise implementation of the purge fold. And when I do that, but with increased data, right? So when I in this particular notebook that I shared, what I'm doing is I'm using fold 1 and fold 3 to 5 as part of the set, and then validating on the test set. And when I do that, the result is better, but still not as good as 339, right? It's getting close to 3438. Right? And as I said here, the only difference in this is I kind of put in, a random state of 1, 2, 3, 4 compared to I don't know what he uses. He doesn't give any random state, so it just starts somewhere. But you see that when I do that and make no changes, that means there is still leakage here, then it gives me the same score as before. So the random state didn't have any particular change in it. This two are the more accurate CPCV implementation. I like this one. And in fact, the other one that I want to try, but it's a little more complicated coding that I'm in the process of coding up, is to do what the example that we saw last week with the graph and stuff. That is, if from 5 folds, if you wanted to use 2 folds as the test and 3 folds as the train, as long as you are still purging, then that should still be okay. Remember that what I did in this particular version modified was I used 4 folds to train and 1 fold to validate. But instead, if I were to use 3 folds to train and 2 folds to validate, then that's something, I mean, obviously because of the complications of which fold you are using and how the coding of it is not as simple as what I did here. So that's something I'm working at, but that's something that I intend to try next to see whether it, further improves the score and gets nearer to it. But the bottom line is I would trust these methods much more than this guy, even though we end up with a better score on the public leaderboard with that approach.
Yeah, it may be that those methods have a classical way of using those historical methods, so that results in a more robust score.
You mean these two?
Yeah, these two.
Yeah, yeah. Because you can trust them more. The CV, at least the CV scores, and you can see the CV scores worsen if you look at, because it just print the CV scores. So to give you an example, let's look at the CV scores here, right? See here, you see for example, for first fold, right? You can see the CV scores is in the 6.8, 6.7, then again 6.7 for or something like that in the 6 point something for the second. The third is again 6 point blah, blah, blah. So, but you see a little more of the 5.9 beginning to appear, but all these are okay too. Fourth is 5.9, 5.7, stuff like that. And then obviously the fifth fold, you have to kind of take with a pinch of salt because of the fact that, we are training on the entire fold, but we are just validating on one day. So that's why I think these get better scores. So this fifth one, you always have to take with a pinch of salt because of what I just explained. And then, he got average across all folds is brought down to this. And then obviously he adds the sixth fold because of what he does, which I think also is a good practice, which is you take the best iterator values and then train that model on the entire data set, regardless of fold, and use that as one of the ensemble models as well. Now, if on the other hand, you will see, so remember, we've seen mostly sixes, fives towards the end, and then, 4 for the last four. Now, let's look at this guy. You see, this one is the one where I've used more than just one fold to train. Still testing with just one fold. Then you can see you can see that, these are 6.7, which are a little more, then 6.3, 6.2. Then even the third fold is 6 point. By this time, we have seen some fives appear in that training with the overlap data. It's still 6. And then you begin to see a little bit of a 5 appear. And then the last, in this case, because I'm just using more to train, but the validation for the fifth is still the single date. So again, you'll see low. And the overall thing is still higher than what you saw when there was leakage. Okay. So that's kind of what at least I was up to over the week, trying to understand PERT's validation and making the changes to conform to what I believe the way it should be, and then see what my results were. But of course, the other thing which Raquel and Steve have been trying, which I think Steve even got it to work, but I have to, that we discussed in the last couple of discussions was obviously all this is done with respect to data that we already have available. And anything we do in CD and stuff doesn't yet utilize the data that is provided to us by the API. So one of the things we can do, which is Steve was beginning to do, was as the data begins to come in for the new dates, see whether we can incorporate that into our training data and see whether that improves our prediction, as it should, because it's using new incoming data to kind of re-update our model, using that to do the predictions. So that's something that we'll learn more about once Raquel and Steve are back next week. So how to do or what are the issues. We discussed some of the issues already, but I haven't tried that part of the implementation yet. I wanted to kind of focus on CV, get that done right, and then, and as I mentioned, I'm still one step away because what I want to do is do this 5 choose 2, which means I'll have 10 groups of such attempts. That is, out of the 5 folds, I can use 3 folds to train and 2 folds to validate and see whether that gives me any better results than what I see. Complex because you now have to you now have to combine. It's not as simple as even what I did with my fourth one. I have to kind of choose and make sure that the combinations are appropriately, or the dates are appropriately chosen based on the combinations.
Yeah. This does has a lot of factual information, so I was kind of diving into it. And yeah, the CPCV one is also nice. The classical methods, the robustness of it. So yeah, I like
Yeah.
both the approaches here.
And I think there's another notebook which is just a Rapids version of the same thing, just using Rapids, so it just kind of implements it faster, but the basic idea is the same. That's why it ends up with almost the same score. And the other thing is, here is the purging embargo as the guy tries to explain it. But again, I'm not sure whether this explanation is perfectly correct or not. I haven't looked at it, but he has at least the reference to the book from which this whole method is taken.
Okay. So this embargo is a specific term, or is it?
Yes. So embargo, if you recall, what he did at the ending of a particular fold, where he added the end gap plus a purge. So you can think of the embargo as the gap that you add. In essence, if you look at the book, he refers to anything where if there is a train following a test, then what you do there is effectively refers to as an embargo. Whereas anything following a train and between a train and a test, he refers to as a purge. But in effect, if you provide gaps between a train and a test, then and ensure that the overlap doesn't or overlap prevents the test data somehow be leaking into training, or the training data be impacted by the test, then you're fine. So in effect, what the guy has implemented of a couple of dates prior and about 7 dates post the end date is good enough for practical purposes. The only question is, given that, how do you then use the folds? And I think the way he has done it is wrong, because it allows for leakage. And by the way, if you look at the comments, many people have pointed that out, and he acknowledges that, yeah, there is a leakage, but he ends up with a better score. So that's still puzzling. But then you can obviously randomly land up with a better public score, and that doesn't mean that your model is going to perform better when it sees new data.
Mm-hmm.
Any other questions or comments from anyone else? Terence, were you able to make any progress?
No, I have not.
Submitting?
Have not.
One that Steve mentioned last session, just trying to get it to run and submit. So I'm still kind of there.
Hey Gautam, thanks for joining. Are you interested in the tabular kind of competition and stuff, or just checking it out?
Hi. Yeah, I would be interested in it. Yeah, I've not looked at the competition yet, so I will have to look at the data and see what it's about. Maybe I might look at the old recordings as well. Hopefully I'll be able to say something in the next week. Yeah.
Sounds good. Yeah, take a look at the recording, because I think that will kind of get you jump started on some of this, whatever we are talking about combinatorial. And the last 2-3 weeks are the most relevant. It's only been about 3 weeks since we started on this competition.
Okay, I'll do that.
How about you, Emily? Any submissions?
No, no submissions. I've been just kind of playing around with getting the data pre-processed, trying to start more or less from scratch. So that's been going slow.
Okay. Yeah, I think the features are something else I haven't spent a lot of time figuring out. There may be, creative work. There's also some commentary about, that's something else I wanted to try, that there is a day of the week feature that the guy has created. And there have been comments from multiple people saying, actually, let me into it while I talk so it's not abstract. So, here is, obviously the memory optimization is important, but that's not anything radical. If you've handled tabular data before, one of the simple things that they always do is making sure that data is in particular types. And that's essentially what is done here as well. So that's not unique to this competition or to, in general, in any of the tabular data. And even if it's not tabular, one of the things you want to do is make sure that all the data has types, and the types that you would, instead of it being objects. So that's what this memory optimization does, is basically ensure that every data in the table has a particular type that it uses. And then this is where a lot of triplet imbalance and, combinations and creating values that matter. This is where a lot of the feature engineering is taking place. And here are all the imbalance features, that combination of things of reference price, var price, near price, ask price, bid price, and then the weighted average price, and then all the different sizes, and then you combine all of these. But then, and then you have these different terms to create the various combinations of these. But the one I was referring to and that people have commented on is there's also the day of the week feature. This is the one I'm referring to, right? So basically you take the date ID, you have the 480, right? So you then divide it in the fractional file. That means you're actually saying, oh, day of the week. But some people have pointed out that this is not as good a feature to use. So I intend to try and do the whole thing with and without this to see whether it makes any difference. Seconds and minutes don't matter because seconds and minutes are seconds and minutes regardless. But there's some confusion as to whether the data provided is actually every 5 days, or does it have any other implications? And therefore, there's some commentary you can read in the comments section of the original 5-fold CV notebook, where some people have recommended that maybe you shouldn't use this feature. And I intend to try with and without that and see whether it matters. Also, you can look at any of the other discussion to see whether there are any more features that people have used and incorporate them in here as well. Those are a couple of other simple things to try if you're fiddling around with this notebook. Okay, that's kind of all I had for this week, and hopefully next week, we'll have more discussion as more people try, and I think Steve will be back too. So he has a little marginal improvement on this notebook. I'm trying. His best score, I think, is now at 3.87, whereas 3.39 is what you get if you just run this notebook. And so he's obviously a little better than that, but just to show you at the margins, these things can cause a swing of like 50 to 100 ranking stuff. And we'll discuss with more about the CPCV method and the various ways that you can utilize. Hopefully I'll have the 5choose2 so that I can validate with 2 folds and train with 3 folds and have that implementation next week.
How's the book, The Advances in Financial Machine Learning?
it's useful, but it's not. I wish it was written, at least for me. Some of the things are well explained, but some others aren't. Like even the combinatorial thing, I wish, he had explained it even better than what he has done there. And especially this thing about why the combinatorial stuff matters. And we can discuss more when Dekal joins, because I kind of want to validate my thoughts there as to why the combinatorial piece matters. And I'm not 100% sure of that, and we'll discuss that more next week. So the book is good, but I would say it's important. Sorry?
Is it a good read?
Yes.
Okay.
It's not very complicated or anything. It's a good read. The only thing is it's absolutely focused on financial aspects. So that's the part. It's heavily focused on finance, and so if you have some interest in that, it's obviously even more useful because it talks about, and in fact, that's where I caught wind of the fact that, the combinatorial thing matters, because if you are able to identify the tests, again, I'm referring to the diagram. I don't want to go to the trouble of pulling it up and stuff right now, but if you look at our discussion previously, the parts that we talked about, the parts are chosen so that the test sequences are in time ordered sequence. And the reason that seems to matter is because when you order the test portions of the folds in time sequence, then you can do a profit and loss calculation directly by using the folds. You see, because they are one after the other. So if you're just calculating profit or loss from your strategy, then you will need folds to be in time sequence in the parts, because only then can you add the profit you made in the first to the second, to the third, to the fourth, and end up from the beginning to the end. No other method where you scramble the times will result in a P&L kind of approach being valid. And I'll talk more about that next week with the picture and stuff like that. But that's the reason for the combinatorial part of it. So these type of things, you get an idea only when you read the book, because that's specific to the domain of finance. Like if you're predicting energy, it doesn't really matter, right? Because you're predicting energy, right? Like energy consumption or energy production or things like that. It's still time sequence, but there's no concept of, energy produced at the beginning to energy produced at the end in sequence having some. But a profit and loss thing, for example, or a kind of like a stock strategy would mean, if you're applying a stock strategy and you want to calculate the P&L of the strategy, you need the test sequences to be in sequence to say, I started with this, ended with this, and then you can add. Otherwise, you can't. That's at least my understanding of past, but I want it validated by a couple of other people diving into it and see whether my understanding is correct or there are issues with it.
Yeah, as I would also like to dive in it, so let's discuss it next week then.
Yeah. So Rakhil, I know, is also intending to do it, although he's been busy, but we'll see whether the discussion next week we can figure out. Okay, good deal. Thanks everybody for joining. And if there are no more questions, then we're done. Any more questions or discussion?
Nope, not for me. Thank you.
Okay, sounds good. See you all next week.
Thank you.
Thank you. Take care. Bye.